All right, so the nice thing is well, first, the bad news. Yeah. Yeah.
Thank you.
Okay. All right, the bad news is there's a ton of formulas. The good news is this chart you have, we're going to eventually fill it out and you'll get to use that on the quiz. You don't have to memorize it.
Yes, you are a great human being.
Okay, so how do you, first of all, can you see the different pictures? This is a double cone, okay? You put one cone on top of the other. You can actually take a slice through the middle, and that's a circle. If I tilt my slice, that gives me an ellipse. And if you can remember back to preschool or kindergarten, we called it an oval. Okay, but the technical mathematical term is it's called an ellipse. Then you can, if you slant it even further, we get the parabola. And what you learned in Algebra 1 and Algebra 2 is that parabolas open up and down. And this year we've seen that parabolas can actually open to the right and left. And so now we're going to figure out how all that stuff works. Then we have our fourth conic section. So there's 4 conic sections: the circle, the ellipse, the parabola, and the last one is called the hyperbola. If you actually take and make a slice that'll hit both cones, they'll have 2 sort of almost like parabola pieces, okay? But when you have the 2, that's called a hyperbola. So it says how to tell which conic you are working with based on its equation. If you get everything on one side equal to 0, you want to ask yourselves these questions, and this is like a flow chart. I don't know if you've ever heard of a flow chart where you go yes, no, and if it's yes, you go one way, no, you go another way, okay? So number 1, is there more than one squared term? If there's only one squared term, it's a parabola. You're done. If it has more than one, you go on to question 2. Do the squared terms have the same sign? If x squared's positive and y squared's negative, you stop. That's a no. It's a hyperbola. If it's yes, are the coefficients the same? If they're the same, it's a circle. If it's no, it's an ellipse. So an ellipse is an elongated circle, okay? It's just stretched out. So let's look at a couple examples down here below. Using this flow chart, classify each of the following equations as either a parabola, an ellipse, a circle, or a hyperbola. So take a quick moment, scan through, and ask yourself the question. Start with question 1. It might be a parabola and you're done. All right, so number 1, do you see there's an x squared and a y squared? So it's not a parabola. Do they have the same sign? Well, 3x squared and 4y squared are both positive. Do they have the same sign? Yes, so I go on. Are the coefficients the same? 3 and 4? No. It's an ellipse. Do you see how I'm doing the questions? Number 2, I have x squared, but there's no y squared. Is there more than one squared term? No, it's a parabola. Okay, you guys try 3 and 4 if you haven't already. Oh, you guys did. You guys are fast. All right, so, oh, not all of you? All right, I see some of you are done. So you have 5y squared, x squared. So, yes, it has 2 squared terms. Do they have the same sign? Yes. Are the coefficients the same? Yes. It's a circle. Number 4, is there more than one squared term? Yes. Do they have the same sign? No. It's a hyperbola. Yeah. Goodness sake, why are you guys borrowing the calculators?
Because we have a science post test.
Oh, okay. Yeah, Jenna?
What does it mean by like they have the same sign?
The same sign is, are they positive or negative? So do you see, here, this was a 3 positive and that was a -7, okay? Okay. All right, so now you have some things to write down for me. Under parabola, this might be on the next page. A parabola is the set of all points x, y in a plane that are equidistant from a fixed line, that's called the directrix, and a fixed point called the focus, not on the line. If you go to Calculus 2 in college, you'll use these conics. So we think Kenzie's coming back, right? Hopefully. Joey's absent. Rochelle is on a field trip. I have graded most of the post tests. I'm still finishing up a few. They're pretty bad for this class. So I know I didn't do any like review packet, but I shouldn't have. This was like stuff we've learned this year. You're supposed to remember what you learned. So I don't know. I'm a little bit concerned about calculus next year. All right, so there should be a little bit of space here. If this is your coordinate grid, let me kind of, what's new for us is this thing called the Directrix and the focus. So say this is my vertex. The focus is inside, and then the Directrix, this is going to be a distance of what we call P. And the distance from the focus to the vertex is P, and from the vertex to the Directrix is a length of P. Okay, so maybe we could write that down. From the focus to the vertex is P units. And then from the vertex to the Directrix is P units. The vertex is halfway between the focus and the Directrix. You have an axis of symmetry, which we learned that earlier this year. Then here's what's new for you, the standard form. And what I want you to do now is take out that chart, okay? Take out the chart, and in the first parabola, write the first row of standard form. The x minus h squared, this goes in the standard form box, okay? You're in your first row. Your standard form is x minus h squared equals 4p times y minus k. In the second row for parabola, you're going to put y minus k squared equals 4p times x minus h. Underneath the column that says shape, the first one is up down, and the first one is right left. We'll figure out the other spots, but at least get the first and second column for parabola. Standard form, and there's your shape, standard form, shape. And then there will be a day where I put them all together too for you. Okay, so then what we want to do is we want to change it from what's called the general form to standard form. And so then there's 5 steps here to the right, and I think I numbered them for you, so go ahead and try to write quickly for me. And something I want to mention, this is a college course. You're getting college credit. It's not the same as a high school math course. So what that means is you're not getting everything inside our class time. That means you need to be reading through your notes once or twice every day. If you're not doing that, that might explain why you're lost or overwhelmed. You're not doing the part that you're supposed to be doing. So, you know, I'm going way too fast for you. You're just writing this down, and it's not, gelling and sinking in. That's supposed to happen outside of class. So if you think that you're supposed to just know everything at the end of class, you have a misunderstanding of a college course. A college course is you take down information and then you are learning it outside of the class time. So let's make sure we get that clarified. Especially those of you going on to the CCP calc with me next year. And if you're going off to college, I mean, if you're taking psychology, sociology, your science, you're not going to learn everything in the class time. You go outside of class, and then you're trying to solidify things. All right, so here we go. If I have x squared minus 8x plus 11 equals 0, and I want to put this in standard form, what you want to do is you want to look at and you'll have your chart with you. And you have to understand, you identify what is it. It's a parabola, and that tells you which row to look at. I have an x squared, so it's of this type. So what that means is I want to complete the square with the x squared, okay? So I take x squared minus 8x. It says make sure the leading coefficient is 1. It is. Step 2, move the constant to the other side, and then you're going to complete the square. We reviewed this earlier this school year, and you did it in Algebra 2, and you may have done it in Algebra 1. You take half of 8, which is 4, and square it. So this becomes x minus 4 squared equals 5. Then it says move the constant back over. So there is my standard form, and then my vertex is 4, -5. Remember, vacuum often in socks only. Same as the inside, or excuse me, opposite of the inside, same as the outside. Yeah.
Now, is that just simply because standard form works better with the cones when you're graphing that three-dimensionally? Or how come you're putting it in standard form?
Just to identify your vertex.
Okay.
Yeah. All right, so let's try it again. You're going to, it says get the leading coefficient to be a 1. So you're going to divide everything by that coefficient of x squared. That's called a. Then move the constant to the other side, and let's go ahead and be proactive and leave a space here. We can save ourselves one step. Take half of 6, which is 3, and square it. Now, when I go to add it over here, 9 is 18 halves. So that's x minus 3 squared equals -5/2, and then bring the constant back over. Oops. So my vertex would be 3, 5/2. All right, so again, make sure you read through this. Okay, make sure you're reading through this a few times because this will not instantly make sense. All right, finding of the focus. Okay, the focus is connected to this p-value. So I wrote the steps down for you. It says convert to standard form by completing the square. Identify the vertex and then solve for p. Decide if the parabola opens up or down or left and right based on p. If p is positive, it goes up or right. If p is negative, it's down or left. Up, down has x squared. Left, right is y squared. Okay? All right, so look at example 1. So what I'm going to do, you can tell the vertex is -3, 2, right? Now, I'm going to subtract the -8 times y minus 2 form. And what I want you to notice, because it's an x squared, it's going to open up or down. So the standard form we wrote down was x minus h squared equals 4p times y minus k. Okay, this is my general form. So can you tell that 4p is in the spot that -8 is holding? Can you tell that looking at that standard form? So then p is -2. Because p is negative, this opens down. So here's what I want you to think about. This is -3 and up 2 is my vertex. It's going to open down, and P is going to be inside the parabola, directly down from the vertex. So if I'm at -3, 2, what would be the coordinates of the focus? If you go down 2 units. -3, 0. And then the Directrix is halfway up. This actually ends up, once you get the hang of it, it's actually not bad. Then my Directrix is y equals 1, 2, 3, 4. I always like to draw mine and reason it out instead of trying to memorize something. And you might be wondering, okay, who gives a rip about conics? Well, if you have or know anything about satellites, satellites provide us internet, cell phone use, lots of other things. There's a lot of national security stuff where they use satellites. They're shaped, satellites are shaped in a conic section. So there's a lot of really good stuff with this. Okay, so let me talk you through it one more time before we do the next one, okay? Because it really isn't that bad, but right now it should be pretty foggy, pretty muddy. So here's the deal. You want to determine, okay, there's an x squared and a y. So that's telling me it's a parabola. If it has an x squared with a y, then it opens up or down. So then you're going to want to look at your chart initially until you kind of get familiar with these. This is the general form. Then I move that y term over and I find p. P is the distance from the vertex to the focus and the vertex up to the Directrix, okay? Now, if it opens to the right, it's going to be, the focus will be P units inside, okay? The Directrix will be on the outside. So let's try another one. So look, I'm going to need to, and I'm going to go ahead and move the 8y and the 9 to the other side. And I can tell it's an x squared and a y, so we're going to do parabolas only, okay? This section's just parabolas. I'm going to take half of 2, which is 1, and square it. So this is x minus 1 squared. And let's go ahead and, I guess we can make this negative 8y minus 8. And you can factor out the negative 8. And so what's my vertex here? How about 1, negative 1? Okay, so now this is the same general form as number 1. So negative 8 is 4p. So p is negative 2. So this one opens down because it's an x squared and p is negative. So we're going to go 1, negative 1. That's my vertex. It's going to open down. So then my focus, and what's interesting, and I'll have to do a little bit of digging here, is that focus is like a location where you can find a place to put something, you know, like on your satellite dish, and sometimes it has to do with sound. If you've ever been to Washington, D.C., have you ever, and I went on a class field trip with one of my kids in 8th grade, and there's a room that if you stand in one spot and you go to the other, I think it's the ellipse, there's 2 focuses. There's a second spot you can go stand, and you can hear everything from that other spot that's far away. And I guess when they were doing stuff, the founders of the United States, that they were listening in on different discussions and stuff, and they were spying. It's like, whoa, bad stuff. But that's what they were doing, because somebody knew their math. So here we go. I am 2 units down. So here's my focus, and make sure you are writing it beside the picture as well as on the picture. That's 1, negative 3. Then my Directrix will be 2 units up. And so you're going to draw that. And my Directrix is a horizontal line, so it's y equals 1. Now, they don't all open down, okay? That just happens to be the first 2 that we did. So let's see one that might open right or left. So let's look at number 3. Let's add 4x, and I can tell it's a parabola because I have an x and a y squared. This is going to be a left-right because of the y squared. So my coefficient is 1 in front of the y squared. Let's not glance over that, but each one, it did have a 1. Take half of 4, which is 2, and square it. But you have to remember to add it to both sides of the equation. That's y minus 2 squared equals 4 times x plus 1. Now be careful. The vertex, the x coordinate comes first, and it is the opposite of the x, the same as the y. So my vertex is negative 1, 2. So now this one is a left-right, so it's y minus k squared equals 4p times x minus h. So this one, 4, is in the 4p spot. Thank you, Shelby. So p is 1. So this is going to open to the right. So let's start a picture here. So So I'm at negative 1, 2. This is the vertex. It's going to open to the right. And if you notice, I'm not plotting any other points. Okay, you're just making a U shape is fine. Now, the focus is always inside. And we found P to be 1, so I'm 1 unit inside. Call it F, and that's 0, 2. The Directrix will also be 1 unit on the other side, but the Directrix is vertical this time. So the Directrix is x equals negative 2. So let me go back through the whole problem one more time. And then the back is just doing the same thing but backwards. So in number 3, we completed the square, but this one, because it's a y squared with an x, it's going to open right or left. You identify your vertex, but it's always the opposite of the x value, same as the y value. So it's negative 1, or, yeah. Well, you know what I mean, right? It's negative 1 and then 2, because this one was 1, negative 1. Then you find what form is it, and you'll have it all on the chart. So 4p equals 4, so p is 1. And so it's going to open to the right because p is positive 1, and it's 1 unit in, and then the Directrix is 1 unit. Notice the Directrix is running parallel to your vertex, okay? All right, now, let's look at the back, the last page here, and it says, find the standard form of the equation of a parabola with the given characteristics. So it says, suppose I know that the vertex is negative 1, 2, and the focus is negative 1, 0. I automatically know which way this opens. Can you tell which way does the parabola open if the focus is underneath? It's going to open down. So then, if it opens down, I automatically know it's x minus h squared equals 4p times x minus, whoops, not x, y minus k squared. And P is the distance from the vertex to the focus. It's 2 units, but because it's opening down, P is negative. Does that make sense? P is the distance from the vertex to the focus, but up is positive, down is negative. Right P is positive, left P is negative. So this is going to go x plus 1 squared equals 4 times negative 2, y minus 2 squared. So that's x plus 1 squared equals negative 8. Whoops. You guys, I'm crazy. Why didn't you catch me? That's not a, this is down, so there's no square here. What am I doing? And that's y minus 2, sorry. All right, how about you guys try 2 and 3? Let's see if you guys can do that on your own. I'll give you a head start. In number 2, if the directrix is at x equals -3 and the vertex is at 0, 2, which way does this open?
To the right.
To the right. It's going to open to the right. The directrix is on the outside of it. Okay, it's on the outside on the opposite side. It opens right, so P is 3. So this is if it's going to open to the right, that's y minus k squared equals 4p times x minus h. So that's y minus 2 squared equals. Now p is positive because it's to the right, and then it's just times x because it's 0, okay? X minus 0. Ooh, now number 3 is tricky because it gives you the focus and the directrix. And it does not give you the vertex. So let's say this is up at 8. But from one of the initial things we wrote down, where is the vertex?
The directrix, the focus.
Yeah, your vertex is halfway between the focus and the directrix. Okay, your vertex is halfway between your focus and your directrix. So where is the vertex? 0, 4. Well, then this opens down. So P is -4. So I'm getting x squared equals -16 times y minus 4. Okay? All right, in your packet of stuff, after the next one is the Parabola Worksheet. Okay, there's the Parabola Worksheet. It's a front side only. 1, 2, and 3 say find the standard form. So use your notes. In 4, like I like to sketch it to help me to come up with the standard form. 5, 6, 7 are sketches, and 1 through 5 are really simple. Use that flow chart question to figure out which is it an ellipse, parabola, hyperbola, or circle. Okay? So that's due tomorrow.
You said when it comes to this, we'll have the.
You'll have that whole chart filled out by the time we're done.
Are you allowed to use it?
Yes.